momentum. This is a word that we hear quite a bit in our society, but we don't really understand what it is from a physics standpoint. So basically, momentum is, as Isaac Newton called it, a quantity of motion. Now, basically what that means is momentum is how much, a measure of how much motion an object has. When an object is traveling fast, or if it's really heavy, then it's going to have more momentum. Momentum depends on a couple of things. It depends on mass of the object, and depends on the velocity. And that's why the symbol for momentum, the equation for momentum, I should say, is P equals m times v. Now, for some strange reason, P is the unit, or the symbol that we use for momentum. I don't really understand why we use a P. I've never actually looked that up, but we use a P for momentum, and so of course mass is the m and velocity is the v. So P is mass times velocity. So the faster you're traveling, the more momentum you have. The bigger you are, the more momentum you have. And so the units of momentum, since mass is measured in kilograms and velocity is meters per second, then momentum is a kilogram meter per second. That's the standard SI unit for momentum. Now, as we learn from Newton's second law, the force on an object is equal to its mass times its acceleration, and acceleration is defined as a change in velocity over time. So, if I take that change in velocity over time, if I were to take this equation and do F equals m times my change in velocity over time, if I then multiply both sides of the equation by t, t's cancel out over here, and I am left with a equation that looks like this. F times t equals m delta v. Well, this F times t has a special name and a special symbol. We call it J, which stands for impulse. When you apply a force for a certain amount of time, it is an impulse, and as you should be able to see from this equation, the impulse causes a change in velocity, and if my velocity changes, m delta v is going to change my momentum. So the momentum equation that you see here, P equals m times v, tells us that we now know, we now know that a change in momentum comes from a force times a time, and that force times the time is our impulse, J, which is our change in momentum. So change in momentum will cause an impulse. This is one thing that we need to recognize, that when we have a object that is traveling in one direction, like say we have a ball that is moving along like this, or moving back and forth like that. Let's say it starts off with a velocity in this direction, and it's got a mass of something, so it has a momentum, mass times velocity. Well, let's say that this mass is traveling this direction, and that's moving, and there we go. Let's say that the ball is moving over here, and then it hits something. When it hits a wall, say there's a wall here, it hits the wall, it's going to be in contact for that wall for a certain amount of time. We'll call that force times time, the impulse. That impulse is going to cause it to change its momentum. It's either going to cause it to come to a complete stop, so like the ball hits the wall and stops, or it could cause it to hit the wall and bounce back, which would be a change in its momentum from this velocity to this velocity. So that's the one thing that is important to note, that this is mass times velocity, which means that the direction matters. That is a helpful point for you to think about. Direction matters with momentum. It didn't matter with kinetic energy, because kinetic energy was based on your speed, whereas momentum is based on velocity. So it does take a force and an amount of time. It takes an impulse right here to change that momentum. So it's important to recognize that this impulse will change your momentum. Anytime there's a force times a time, momentum is changing. You're now about to get a worksheet handed to you that is going to encompass all of this stuff. So let me just stress to you that a couple of equations that you need to know and be familiar with. Let's move that off and just have you look at just the equations. Momentum equals mass times velocity. And if I change my momentum, then I'm going to get my mass times a change in velocity, because the mass is not going to be changing. Let me make that blue too. Yeah, let's start. Yeah, anyway. So, in order to change my momentum, I have to have an impulse, and that impulse is caused by a force times a time. So that means that the end result of all of this is one lovely equation that you could have as a force times time is going to be your mass times your change in velocity, which is always going to be your final velocity minus your initial velocity. So if you remember these equations, it's pretty simple to do momentum problems, and as always, we hope you have a good day.